Section 4.2 is trigonometric functions defined on the unit circle. So the unit circle consists of all points x, y that satisfy the equation x squared plus y squared equals 1, which is a circle of radius 1. And it says see the back page for the unit circle. So in your packet, just before the answers to the practice on your own problems is a blank unit circle. So the center of our circle is at 0, 0. So before we can really answer these questions, we need to make sure that we're all on the same page about what the unit circle is. So if you flip to the back page, you'll see this, or the page that I'm talking about, you'll see your blank unit circle. And there's actually a very systematic way of filling in this circle. Once you know how to fill it in, you can then easily extract information or just draw the pieces of it that you need on the exam. So there's a pattern that's followed all around the circle. So the first thing we need to realize is we're in the xy plane. So this is the positive x-axis. This is the positive y-axis. We have the negative x-axis and the negative y-axis. Because we have a circle of radius 1, we can label all of our quadrants, right? We know we are 1 unit away from the center. Up here, we are 1 unit above, so this is at 0, 1. Here, we're 1 unit left, so that means this is negative 1, 0. And down here, we are 1 unit below the origin, so it's 0, negative 1. So each of these quadrants are 90-degree angles. Within each quadrant, it's segmented the following way. We chop it in half, so this is a 45-45 angle. And it's also sliced into thirds. So this is 30, 30, and 30. So to do the degree measures, it's actually very easy. At 0 degrees, or the x-axis, excuse me, is 0 degrees. Then we go up to 30 degrees. So 30. This is the line that cut it in half, so that's 45 degrees. And then we have another 30 here, so this is 60. And then we're at 90. So the pattern that you see within each quadrant is 30 plus 15 plus 15 plus 30. And so we can keep following that all the way around the circle and getting our angle measures. So if I add 30 to 90, I'm at 120. When I add 15, I'm at 135. When I add another 15, I'm at 150. And then I add 30, and I'm at 180. Plus 30 is 210. Then I'm at 225. Then 240. And then 270. Add 30, we're at 300, 315, 330, and then we're back up to 360. To get the degree measures, okay, or the radian measures, the radian measures follow a pattern as well. So we already saw that 90 degrees is pi over 2. So this is pi over 2, and this is 0 radians. So in the first quadrant, they count in a very specific way. So it goes pi over 2, pi over 3, pi over 4, there is no pi over 5, and pi over 6. So we can now see pi over 6 is 30, pi over 4 is 45, pi over 3 is 60, pi over 2 is 90. To fill in the rest of these, we count, just like we did with our degree measures. But the way that you should do this, because all the angles you're used to seeing on the unit circle are reduced. So what I always like to tell people is go big, then go small, and you'll actually get a cool little overlap going on. So the first angle I want to deal with is 90 degrees. Those are easy because they're 40, or 4 of them. So we have 1 pi over 2, 2 pi over 2 is pi. Then 3 pi over 2. So I'm just counting in increments of pi over 2. Then I have 4 pi over 2, and 4 pi over 2 reduces to 2 pi. Then I would count 45 degrees around, because there's going to be 8 of those, and it splits in half. So 45 degrees, right, is pi over 4. Well, I have 1 pi over 4, 2 pi over 4, which simplifies to pi over 2, 3 pi over 4, then 4 pi over 4. So what you'll see here is you're going to get some overlap of your previous count, and as long as they line up, you know you're counting correctly. So 4 pi over 4, 5 pi over 4, 6 pi over 4 is 3 pi over 2, and then 7 pi over 4, 8 pi over 4, you're back at 2 pi. Then we said, well, the rest of these are all chunks of 30. So if 30 degrees is pi over 6, I get 1 pi over 6, 2 pi over 6 is pi over 3, 3 pi over 6 is pi over 2, 4 pi over 6 simplifies to 2 pi over 3, 5 pi over 6, 6 pi over 6 is pi, 7 pi over 6, 8 pi over 6 is 4 pi over 3, 9 pi over 6 simplifies to 3 pi over 2, 10 pi over 6 simplifies to pi over 3, 11 pi over 6, and then 12 pi over 6 is 2 pi. So you can very quickly just count around in increments like you would count change, right? Like if you're counting nickels, 5, 10, 15, 20. So now to fill in the points, this is really cool. All of our special angles either have a 1, a 0, a square root of 2 over 2, or a square root of 3 over 2. So this is where you take advantage of the xy plane. So every one of the interior points, right, we've already taken care of the outside, are all numbers over 2. And in the first quadrant, everything is positive, all the x's and y's. So now it's just a counting game. So what you want to do within each quadrant is pick a 0 and walk to 1. So I'm going to pick the 0 in this point, and it's in the y position. Then within that same quadrant, find its corresponding 1. So here's y equals 1 in this quadrant. So what you're going to do is you're going to walk from 0 along the y values to 1. And the pattern is the square root of 0 is 0, square root of 1, which is 1, square root of 2, square root of 3. Then find the other 0, which is in the x position, and count toward its corresponding 1. And it's square root of 0, square root of 1, square root of 2, square root of 3. So if you can count to 3, you can fill in these values. So if we go to the second quadrant, over here, all the x values are negative, but all the numbers are still over 2. So we're going to do the same thing. I've got a 0 in the x position, a 1 in the y position, so I'm just going to go 0, 1, 2, 3. So 1, square root of 2, square root of 3. In the y position, we travel in the opposite direction. 0, 1, square root of 2, square root of 3. If we come down to the third quadrant, well, everything is negative. So it's negative something over 2, negative something over 2. So all the x's and all the y's are negative. So here, the first 0 I see is in the y position, and I'm going to go toward its corresponding 1. So 1, square root of 2, square root of 3. 1, square root of 2, square root of 3. And then in the last quadrant, the x's are positive, but the y's are negative. So, once again, I have a 0 in the x position. I'm going to go toward this 1. So 1, 2, 3, 1, 2, and 3. So the other way, we've all completed the whole thing, and when you know this pattern, you can actually do this in like under 2 or 3 minutes. It's actually quite easy. So the other thing we say is, well, since we start the angles from the positive x-axis, we measure the quadrants counterclockwise around. So this is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. When you read the unit circle, all of the points x, y correspond to cosine theta, sine theta. So the x coordinates are giving you cosine of that particular angle, and the y coordinates are giving you sine of that particular angle.